In this video, I'm gonna solve an example of the double integral of e to the power of x minus y over x plus y dA, where the region R is this region that is between these two lines. So let me start by changing the variables. I'm gonna set u to be x plus y and v to be x minus y. Okay, so I'm gonna find the Jacobian of these two to just transform dA, which is the x dy, into du dv. Okay, so I'm gonna say the Jacobian of uv with respect to x and y, it would be the determinant. Let me use this notation for it. The determinant of the matrix u with respect to x, u with respect to y, v with respect to x, v with respect to y, and u with respect to x is 1, with respect to y is 1, v with respect to x is 1, with respect to y is negative 1. So this is negative 1 minus 1, it's negative 2. So I'm gonna say when I have du dv, it would be the absolute value of Jacobian dx dy. So it is negative 2 dx dy. And based on that, dx dy would be 1/2 of du dv. Okay, so let me change the integrand, which is this dx dy, and it's gonna be e to the power of v over u, and then dx dy is 1/2 du dv. Okay, so the third step is to see what happens to the bounds. Okay, so I have x-axis, y-axis, and then I have one line in here, another line in there. Okay, this is 1, 2, 1, 2. Okay, I'm gonna see what I have in u v plane. Okay, I'm gonna start with this one. On this one, x is equal to 0. Okay, so let me write the transformation in here. U is x plus y, and then v is x minus y. So when x is equal to 0, as you see, u is equal to negative y. U is equal to y, v is equal to negative y, so u would be negative v. So u is negative v. I'm gonna have this line in here, u equals to negative v. Then let me see what's gonna happen in here. And here, equation is y equals to 1 minus x. So u is equal to x plus 1 minus x, which is 1, and v is equal to x minus y is 1 minus x, which would be 2x minus 1. Okay, so I'm gonna take this one, which is easier, and this is u equals to 1. Actually, let me move this one a little bit here so that I have more space. So this is, oopsie, let me erase this one. I'm gonna grab one line in here. So this is u equals 1. Then I have this line in here, which is y equals to 0. When y is equal to 0, u and v are equal to each other. So I have u equals to v, and the last one is this one. Equation of that is y equals to 2 minus x. So I'm gonna see u is x plus 2 minus x, so u is equal to 2, which is this line. This is u equals to 2. Okay, so if you want, you can see that v is going to be x minus 2 minus x, which would be 2x minus 2, which would be somewhere else, but I'm gonna pick these ones as my region. And let me just check and make sure that my region is correct, because of what? Look at the region. It is this one, that one, this one, and that one. Okay, very good. So now let me set up the integral. It would be the double integral of e x minus y, x plus y, and then dA over the region R. So transform it into e to based on the change of variable v over u, and then du dv. Actually, let me change it to dv du because it's easier. dv du, and then don't forget the 1/2. Gonna bring it out, and then v is from where to where. If I have to do dv first, I need to graph a parallel line to the v-axis. The first point lies on v equals to negative u. The last point lies on v equals to u. And then u is from 1 to 2. I can graph these lines starting at here up to here. So u equals to 1, u equals to 2. Okay, so it would be 1/2. Let me write the double integral from 1 to 2, then negative u to u e to the u, v over u, then dv du. Okay, when I want to do the inner integral first, it's with respect to v, so u would be a constant. So the answer for this one would be u e to the v over u, and then v is from negative u to v equals to u. So let me write the outer integral. I'm gonna plug in u to the power of 1 minus e to the power of negative 1 times u, and then du. Okay, so 1/2 e minus 1 over e would be the constant, and then I get u squared over 2. U is from 1 to 2. Plug in 2. Plug in 2, I get 4 over 2 minus plug in 1 is 1/2. Okay, so this one would be 3 over 2, so it would be 3 over 6. E minus 1 over e. That's how we change the variables. One more note that I noticed that I didn't mention it, when you transform, for example, this line into uv plane, I chose u equals to v because for the second one, for v, I have it in terms of x, which is not helpful, and I need to change this one in terms of u and v, which would make my life harder. So that's why I chose this one. Also, for transforming this line in here, this line is y equals to 2 minus x, plugging into u and v. U I just got number 2, but v I got 2x minus 2, which is basically in terms of x, so that's why it is not that much helpful. I need to change it into u and v, which would be harder. So that's why I chose u equals to 1 and u equals to 2 to make the area of the integration easier. Okay, that's how we solve this line integral, this double integral.